Let's look at how to rationalize denominators that have two terms, where there's addition or subtraction in the denominator between some terms. This is a little more complicated than denominators with one term, but we can still follow the same strategy for each of these examples. In this case, we're going to multiply it by the conjugate of the denominator. Now, the conjugate in math means with an opposite sign. So the conjugate of two terms a plus b is a minus b. The conjugate of a minus b is a plus b. You just replace that addition or subtraction sign in the middle with the opposite sign. So let's see what happens when we multiply by the conjugate in this example. The denominator is root 3 minus 2, so the conjugate is root 3 plus 2. And we have to multiply by the same amount in the numerator to keep this fraction the same. So we're multiplying numerator and denominator by root 3 plus 2. This looks like a lot of complicated multiplication, especially this denominator. I have these two binomials. I need to multiply them together. I could expand that and write out all the different terms. However, there's a shortcut when we're multiplying conjugates. These are conjugates of each other. And here's the shortcut. When I multiply two conjugates, a plus b times a minus b, the final result is a squared minus b squared. You might recognize this as the difference of squares formula, which we applied earlier in reverse to factor an expression like this. Now let's apply it with multiplication to write our final result. That saves some time in these examples. So in the example we did here, my first term a is square root of 3. My second term b is 2. And so the final result of multiplying root 3 minus 2 times root 3 plus 2 should be a squared minus b squared. What's a squared minus b squared? Let's figure that out. A squared is root 3 squared, which is equal to 3. B squared is 2 squared, which is equal to 4. And so the final result here should be 3 minus 4 in the denominator. There's no radical expression, right? And that's the purpose of multiplying by the conjugate. It always eliminates the radicals. So we have 3 minus 4 in the denominator. We'll simplify that more. In the numerator, I have 5 times root 3 plus 2. And I typically keep my numerator in factored form. I don't usually distribute this out just in case there's a common factor that divides out later on. So let's just rewrite this. This denominator is negative 1, but we don't typically write a negative sign in a denominator. So I'm going to write it out in front of the expression, and you could write it like this: negative 5 times root 3 plus 2 over 1, but since this is a denominator of 1, it's not even really necessary. Here's the final simplified expression. There's no denominator, there's no radical in a denominator. That's the point of rationalizing our denominators. Let's consider one more example. And I know that I need to multiply by the conjugate of the denominator, right? The denominator determines the factor that we multiply by. So the conjugate of the denominator is root 2 minus root 3. And let's multiply by the same amount up here. So we're multiplying binomials again, both in the numerator and the denominator. In the denominator, I can use the fact that these are conjugates. This is a plus b times a minus b, and I can get a final result pretty quickly that way. A is the square root of 2, b is the square root of 3. So a squared is 2, b squared is 3. And so our final result should be a squared minus b squared, 2 minus 3. It looks like once again we'll have a denominator of negative 1. Now for my numerator piece, there's really no other way around it than by expanding this multiplication. We're going to multiply term by term. I have root 2 minus root 3 times root 2 minus root 3. So when I multiply that together, I get root 2 times root 2, that's root 4. Then I have root 2 times negative root 3, so that's minus root 6. I move on to here, and I have minus root 3 times root 2, so that's minus root 6. And then I have minus root 3 times minus root 3, so that's positive root 9. Now, square root of 4 is 2, and we get some common terms here. Negative root 6 and another negative root 6 gives me negative 2 root 6, combining coefficients. And the plus the square root of 9, the square root of 9 is 3. So this final result here should be 2 plus 3, which is 5, minus 2 root 6. That took some time, and I worked it out on the side. Now let's take that and plug that back in to this numerator. 5 minus 2 root 6. That's our result. And then let's finish simplifying this example. Once again, the denominator is negative 1. And so I have 5 minus 2 root 6 over negative 1. But we want to pull that negative sign out in front of the denominator. And so let's pull it out in front, and we have negative 5 minus 2 root 6. If we have a denominator of 1, I don't even need to show it. So I could write my answer like this, or I could multiply the negative sign in and write my answer like this, negative 5 plus 2 root 6. Either one of these would be acceptable as a simplified solution.